In this video, we're going to be introducing quadrilaterals. Quadrilaterals are four-sided shapes. So let's just draw a family tree to give us an idea of what we're about to look at in the next few videos. So up at the top of our tree are all quadrilaterals. Any four-sided shape, right? Four sides. Well, there's a lot of different four-sided shapes, but they are grouped into general families. One of those families is called parallelograms. Parallelograms. Okay. So those are types of quadrilaterals. They have four sides, but they also have a lot of unique properties that make them parallelograms instead of other four-sided shapes. So off to this side we have other four-sided shapes that are not parallelograms. For example, we're going to be talking about trapezoids a little later on. A trapezoid is a quadrilateral. It has four sides, but it is not a parallelogram. We'll talk about some other types of trapezoids later on. What we're going to be dealing with today, though, are this family of parallelograms. So what does it mean to be a parallelogram? Well, there are qualities that make something a parallelogram. Here is one example of a parallelogram, a general parallelogram here. Kind of looks like a rectangle that's been tipped over. That's just a parallelogram in general. They have 5 properties. And these are the things that make it a parallelogram. One is actually that opposite sides are parallel. It's really the biggest definition of a parallelogram. That's why it's called a parallelogram. So there's our symbols for parallel, little arrows pointing in the same direction. So these opposite sides here are parallel to each other. Well, so are these opposite sides. This side and this side. They're also opposite sides and they're also parallel. So there's one thing right there. Another thing about sides, since we're talking about sides, opposite sides are congruent. So this side, the length of that side, is the exact same as the length of this side. The same is true up here. This side is opposite this side, so they must have the same length. Now keep in mind that this length on the right is not the same length as this one on the bottom. But opposite sides are the same length. Okay? So make sure you get the difference there. We got some things about angles here. Opposite angles are actually congruent. And what I mean by opposite is pretty much diagonal. So what's diagonal from this angle, or across from, or opposite is this angle. So this angle is identical in measure to this angle. Well, likewise, this angle is congruent with the opposite side over here, this angle. However, these two angles are not the same. Only opposite angles are congruent. Okay? But since we're talking about these angles over here, that brings us to our next property. Turns out the angles that are on the same side, they're known as same side angles, right? Or same side interior angles is more specific, because they're on the inside of the shape. Same side interior angles are supplementary. Remember that supplementary means they add up to 180. So the angles on this side add up to 180. This one and this one add up to 180. Well, let's look at some other same sides. Down here on the same side, the angles that are on the bottom, they're on the same side. So this angle plus this angle is 180 degrees. Look at the right side. Same side angles on the right side add up to 180. This one plus this one. Same thing on the top. This angle plus that angle add up to 180. Same side angles add up to 180, always in parallelograms. The last one, let's write it first and then we'll draw it to talk about it. It's referring to this thing called diagonals. Diagonals bisect each other. So let's write that down and then let's talk about it. If you remember from past lessons here, a diagonal is a segment that connects two vertices or two corners. So if I connect those two corners by drawing a diagonal line, then it's called a diagonal. Well, this diagonal is actually cut in half or bisected by this other diagonal here. So if I draw two, they cut each other in half. So I just cut this segment into two equal halves. But this first segment that I drew also cuts this segment into two equal halves. Now in a parallelogram, in general, this half is equal to this half, but this half is not equal to this other half. Now we will see in some special parallelograms where they're all equal halves, but in general for a parallelogram, only the half of the same diagonal. So this half and this half create that whole diagonal, and they got cut into two equal halves. Okay. So there's our 5 properties of what makes something a parallelogram. Let's apply these properties and see if we can figure out some missing shapes, some missing angles, some missing sides, just using these properties. So here's our first one. So let's apply some properties here. We're talking about some missing angles, so let's think about our angle properties. We know that opposite angles are congruent, so let's see if we can find any of those. Well, here's 65, and opposite from that is missing, so it has to be the exact same as 65. So y is 65 degrees. What's our other one here? Same side angles are supplementary, right? So they add up to 180. So if we know this is 65 right here, well, z has to be its supplement. So how much more do we need to add up to 180? You can take what we know, 180 minus 65, to figure out what's missing. Or you can just ask yourself, 65 plus what gives you 180? As it turns out, z has to be 115 degrees, because 115 plus 65 give us 180 on that same side. Now you could apply the same logic to figure out x, or you could say, well, since we know this is 115 over here, then opposite must be the exact same. So x is 115, either way you think about it. Okay. So as you begin to practice these, it might be nice to write your reasons for why you're saying the angles are what they are until you get a lot better at it. Let's do another example. Alright, here we're going to start adding some new things here. Again, we got opposite angles are congruent. So we know that if this is 56 degrees, well then x must be 56 degrees. So this is 56 now, right? Well, we could use our same side angles add up to 180, right? Our supplementary. So this entire side right here, we know 56 down here. We know 85 is part of this angle, so 85 plus 56 gives us 141. And so how much more are we missing in order to get up to 180 degrees on this right side here? Well, you could subtract what you know from 180, or you could say, what do I have to add to 141 to get 180? Either way, y is 39 degrees. Now z is kind of tricky here. We can do it a couple of different ways. I'm going to show you one way in particular though. If you think back to parallel lines, we know that this side is parallel to this side. If parallel lines are cut by a transversal, then we know that alternate interior angles are equal. Well, we have right here this angle and this angle. Those are alternate interior angles, so they must be equal. So Z must be 85 degrees. And we know that Y was 39, so that must be 39 right here. And we could check our work, make sure all our sides are adding up to 180. So that was a little tricky to get, but if you remember the rule that parallel lines cut by a transversal create congruent alternate interior angles, then it makes it really easy. Let's see if we can practice that on this next one here. What do we got here? So we got, this is supposed to be a 9 here, so just fill that in. Why is it going away? So this side is 9 units long, let's say. Well, we know that opposite sides are congruent, right? So this side must be the same as this side. So B must have the same value as the length of that side, so B must be 9. Similarly, A and 6 are opposite sides. So this segment is the same as that segment. Opposite sides are congruent. So A must be 6. What else is in this picture? I think we can use opposite angles are congruent. So if this is 75, then opposite from that is X. So X must be 75 degrees. And what's missing is Y. Well, we can do it one of two ways. We know this is 75. So we can either look at the right side and the same side angles adding up to 180, or we can look at the top here and say that same side angles have to add up to 180. Doesn't matter. Either way, you're going to be doing the same math. You're still adding what we know, 75 and 45, or 75 and 45. So that's 110, 120. 70 and 40 is 110. 5 and 5 is 10. So 120 total, right? So how much are we missing from 180? Well, we're missing 60. So Y must be 60 degrees. Alright. So almost used up all of our properties so far. Again, on this example, we got opposite sides here. We're looking at variables that deal with opposite sides. So this 5A must be equal to 30. So let's set it equal to 30. 5A equals 30 and solve for A. And divide by 5. A must be 6. We can do the same thing with our left and right side here. They're equal, so set their expressions or the values here equal to each other. So B plus 2 equals 2B minus 20. Let's subtract B from both sides. So we get 2 equals 1B minus 20. And then let's add 20. And we're nearly done. We get 1B equals 22. So B must be 22. What else do we got going on in this picture? Here we're going to talk about the diagonals. Remember, this diagonal is equal to this half of the other, or the other half right here, right? So Y must be 20. Well, that's pretty easy. X, this half of the diagonal, is equal to this half of the diagonal. So we set their values equal to each other. 2x equals 18. And solve for x. All you got to do is divide by 2. And x is 9. Alright, so that's how we apply properties of a parallelogram to find missing sides and missing angles. just one recap here. Same side angles add up to